Hello, in this lecture we will find out the values of line segments X and Y. In the drawing we have a square DEBF. The square is inside the right triangle, triangle ABC. One side of square DEBF equals to 1 unit, that is to say EF equals to 1 unit and D also equals to 1 unit. And we also know that the hypotenuse of the right triangle ABC equals to 3 units. And we want to find out the values of line segments FC that equals to X and the value of line segment AD that equals to Y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. Side DE is parallel to side BF. And we also know that BC is one side of the right triangle ABC. Therefore, it is a straight line. BC as the side of a triangle is a straight line. And DF is part of the straight line BC and it is parallel to DE. So if part of the straight line BC is parallel to DE, then BC itself will be also parallel to DE. Okay, so BC, the straight line BC is also parallel to DE. So BC is parallel to DE. And we have rule number 1 that states according to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. I'll read rule number 1 again. corresponding angles between parallel lines are equal to each other. So actually, those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other. So we can write down that angle AED, this angle, is equal to angle ECF, this angle, and they are equal to each other according to rule number 1. That is to say, because of the fact that they are located between the parallel lines DE and BC, that is to say DE is parallel to BC, and those two angles are located between those two parallel lines, therefore they are equal to each other. So if we define angle AED as theta, so here angle AED equals to theta, then from this equation theta equals to angle AED equals to angle ECF, we will derive that angle ECF also equals to theta, so this angle ECF also equals to theta. So we found out that those two angles are equal to each other and they are both equal to theta. In the next step I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. We know that AB is one side of the right triangle ABC, therefore it is absolutely a straight line. So we know that AB is a straight line. We will define angle ADE, this angle is angle X. So if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. That is to say, angle X plus 90 degrees must be equal to 180 degrees. Here we subtract from this equation 90 degrees, and we'll get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So I'll substitute angle X by right angle. Likewise, BC is one side of the right triangle, triangle ABC, therefore it is a straight line. We'll write down that BC is a straight line. So if we focus on the upper side of the straight line BC at point F, we define angle EFC as angle Y. Then the sum of the angles on the upper side of the straight line BC at point F must be equal to 180 degrees. That is to say, angle Y plus 90 degrees must be equal to 180 degrees. So here we'll subtract 90 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 90 degrees is equal to 90 degrees. So angle Y is a right angle. In the next step, we will focus on the right triangle, triangle ADE, this right triangle. In the right triangle, triangle ADE, tangent theta equals to AD over DE I repeat again, in the right triangle, triangle ADE, we know that tangent theta equals to AD over DE. But AD equals to Y, and DE equals to 1 unit. So in conclusion, we found out that according to equation number 1, tangent theta equals to y. In the next step, we will focus on the right triangle EFC. On the right triangle EFC, tangent theta equals to EF over FC I repeat again. On the right triangle EFC, tangent theta equals to EF over FC. But EF equals to 1 and FC equals to X. So tangent theta, according to equation number 2, will be equal to 1 over X. I'll repeat again, tangent theta according to equation number 2 equals to 1 over X. In the next step, we'll get equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay? So equation number 3 states that tangent theta according to equation number 1 that equals to y must be equal to tangent theta according to equation number 2 that equals to 1 over x. In conclusion, we found out that according to equation number 3, y equals to 1 over x. Here we multiply equation number 3 by x, and we get that x times y equals to 1 and whenever we have two numbers that we multiply by each other and the result is 1, then it means that 1 is the inverse number of the other. So we can write down that x is the inverse number of y, and y is the inverse number of x. Okay, y is the inverse number of x. for example, we know that 5 times 1 over 5 equals to 1. Therefore, 5 is the inverse number of 1 over 5, and 1 over 5 is the inverse number of 5. Okay? And we also have the rule that every number has only one inverse number. Every number is only one inverse number. So 5, the only inverse number of 5 is 1 over 5, and the only inverse number of 1 over 5 is 5. In the next step, we'll focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars according to the Pythagoras theorem. That is to say, AC squared equals to AB squared plus BC squared. I will repeat again. In the right triangle, triangle ABC according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. AC equals to 3, so AC squared will be equal to 3 squared, that is 9. And it equals to AB squared. AB equals to y plus 1, so AB squared will be equal to y plus 1 squared. Plus BC squared. BC equals to x plus 1, so BC squared will be equal to x plus 1 squared. In conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4, and we will get that y plus 1 squared is y squared plus 2y plus 1 plus x plus 1 squared is x squared plus 2x plus 1. And in the other side of equation number 4 we have 9, that is to say it equals to 9. But according to equation number 3, we know that y equals to 1 over x. Y equals to 1 over x. So actually can substitute y in equation number 4 by y by y by 1 over x, and we do it now, and we get that y square equals to 1 over x square plus 2y is plus 2 times 1 over x plus 1 equals plus x square plus 2x. Again, y square is y 1 over x square plus 2y is 2 over x plus 1 plus x square plus 2x plus 1 equals to 9. Here we will organize the expressions in the question number 4 in a different way, and we will get that x squared plus 1 over x squared plus 1 plus 1 is 2. So it is plus 2 so it is plus 2 plus 2x plus 2 over x equals to 9. The expression inside the brackets x squared plus 1 over x squared plus 2 equals to x plus 1 over x squared. And here we take 2 as a common factor from those two expressions, and we get that here we will have x plus 1 over x. It equals to 9. Here we will substitute x plus 1 over x by t, or we define that t equals to x plus 1 over x. So now we can substitute t by x plus 1 over x in equation number 4. We'll do it now, and we will get that here we have t squared plus 2t minus 9 equals to 0. So here we have a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Actually minus 9. Okay, the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. That is to say, according to the formula that x equals to minus b x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation. We know that t squared plus 2t minus 9 equals to 0. So in this quadratic equation, the coefficients, first of all, the variable that we are looking for is t, so x equals to t. The coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 9. So we will put the data inside the formula for x, and we will find out the value of the values of t, because t equals to x. So here we have t equals to minus b, b equals to 2, so minus b is minus 2, plus minus, so it is minus b plus minus square root of b squared, b equals to 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, and c is minus 9, all divided by 2. So t equals to minus 2 plus minus square root of 4 plus 36 is 40, all divided by 2. So t equals to minus 2 plus minus 40 is 4 times 10, and the square root of 4 is 2, so it is 2 times square root of 10, all divided by 2. So t equals to minus 1 plus minus 2 over 2 is 1, so in conclusion if found out that t equals to minus 1 plus minus square root of 10, that is to say t has two different solutions. The first solution will be t equals to minus 1 plus square root of 10, and the second solution for t will be t equals to minus 1 minus square root of 10 So we will focus on the second solution for t equals to minus 1 minus square root of 10. According to our definition, t equals to x plus 1 over x, and it equals to minus 1 minus square root of 10. X is the length of one side of the right triangle EFC, and length is a positive number, and also x plus 1 over x will be a positive number. So in this side of the equation we will have positive number, and in the other side of the equation we will have minus 1 minus square root of 10, that is actually a negative number. And a positive number can never be equal to a negative number, therefore we have a contradiction. So this solution is not correct. We'll cancel this solution, and we're left only with the solution that t equals to minus 1 plus square root of 10. According to our definition, t equals to x plus 1 over x, that equals to minus 1 plus square root of 10. Here we will multiply this equation by x, and then we will multiply x by x, and then we will divide it by x, and we will get that x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract from this equation square root of 10 minus 1 times x, and we will get that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we have here a quadratic equation. The coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1, and the formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So x equals to minus b, b equals to minus square root of 10 minus 1, so minus and minus is plus, so b equals to square root of 10 minus 1 plus minus b square is square root of 10 minus 1 square minus 4 times a times c. A is 1, c is 1, so it is minus 4, all divided by 2 times 1, that is 2. 2a is 2 times 1 is 2. So x equals to square root of 10 minus 1 plus minus, here we have a square root of 10 minus 1 square. We will calculate the value of this expression according to the algebraic identity that a minus b square equals to a square plus b square minus 2 times ab. That is to say, and a equals to square root of 10 and b equals to minus 1, so it will be equal to square root of 10 square, that is 10 plus 1 square is 1, minus 2 times square root of 10 times 1, minus 4, all divided by 2, so x equals to square root of 10 minus 1 plus minus, here 10 plus 1 is 11, 11 minus 4 is 7, so in conclusion inside the root we have 7 minus 2 times square root of 10, all divided by 2. So inside the root we have the expression 7 minus 2 times square root of 10. We will present this expression in a different way. So here we have the expression inside the root that is 7 minus 2 times square root of 10. This expression equals to, first of all, 7 is 5 plus 2, so we'll substitute 7 by 5 plus 2. Minus 2 times square root of 10. We will substitute square root of 10 by square root of 2 times square root of 5. So, in conclusion, we found out that 7 minus 2 times square root of 10 equals to 5 plus 2, minus 2 times square root of 5 times square root of 10, minus 2 times square root of 5 times square root of 2. Here, 5 equals to square root of 5 square, so we substitute 5 by square root of 5 square. And we will substitute 2 by square root of 2 square. Minus 2 times square root of 5 times square root of 2. Actually, the expression square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square, and here a equals to square root of 5 and b equals to square root of 2. So according to, so I write it down. The algebraic identity is a square plus b square minus 2 times ab equals to a minus b square. In our specific expression, a equals to square root of 5 and b equals to square root of 2. So according to this algebraic identity, we can substitute this expression by a minus b square, that is to say by square root of 5 square minus by square root of 5 minus square root of 2, because a equals to square root of 5 and b equals to square root of 2. So we'll do it now, and we'll get that square root of 5 minus square root of 2 square So in conclusion, we found out that the value of 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. That is actually a minus b square. So here we will turn to our original expression and we will substitute 7 minus 2 times square root of 10 that is inside the root by square root of 5 minus square root of 2 square. We can do it because, as you can see, they are equal to each other. So we get that x equals to square root of 10 minus 1 plus minus, and I repeat again, we substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, all divided by 2. So we got the expression that x equals to square root of 10 minus 1 plus minus. Here we have square and root, and the square cancels the root, and we left only with square root of 5 minus square root of 2. Okay? All divided by 2. So I actually found out that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So we have here two solutions that are possible for x. The first solution, we will define the first solution as x1 and the second solution as x2. So the first solution to the quadratic equation will be x1, that will be equal to square root of 10 minus square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. This will be the first solution to the quadratic equation, and the second solution will be x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 So it is actually square root of 10 minus 1 minus square root of 5 minus square root of 2, all divided by 2. We will continue with x1. We will develop the expression for x1, and we get that x1 equals to, here we have square root of 10, we'll substitute square root of 10 by square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 divided by 2. So here we'll take square root of 5 as a common factor out of this expression, and we'll get that x1 equals to square root of 5 is a common factor. Inside the brackets we will have square root of 2 plus 1, and here we have minus 1 minus square root of 2, so we'll take minus 1 as a common factor, and inside the brackets we will have square root of 2 plus 1 all divided by 2. So here we'll take square root of 2 plus 1 as a common factor, and we get that x1 equals to square root of 2 plus 1 is a common factor, and what is left from this expression after we took from it square root of 2 plus 1 as a common factor? What is left is actually square root of 5, and from this expression what is left is actually minus 1 all divided by 2. So in conclusion we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We'll do the same process for x2. We'll develop the expression for x2, and we'll get that x2 equals to, here we have square root of 10. We will substitute square root of 10 by square root of 5 times square root of 2 minus 1. Here we have minus square root of 5. Minus with minus is plus, so it is plus square root of 2 over 2. So here we take square root of 5 as a common factor out of this expression, and we get that x2 equals to square root of 5 is a common factor, and inside the brackets we will have here square root of 2, and from this expression what is left is minus 1, and we have also plus square root of 2 minus 1 all divided by 2. So here we'll take square root of 2 plus minus 1 as a common factor, and we get that x2 equals to square root of 2 minus 1 is a common factor, and inside the brackets we will have here square root of 5 plus 1 all divided by 2. So in conclusion we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. In the next step we will multiply x1 by x2. So I will copy in the new page the values of x1 and x2, and we will multiply x1 by x2. Okay, so x1 equals to square root of 2 plus 1 times square root of 5 minus 1 divided by 2. And according to what we have already found out, the value of x2 is equal to square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. Okay, so those are the values of x1 and x2. Now we will multiply x1 by x2, and we will get that x1 times x2 will be equal to x1 is square root of 2 plus 1 times square root of 5 minus 1 divided by 2 times x2. x2 is square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. Okay, so this is the expression x1 times x2. In the next step I will organize the expressions in this multiplication in a different way, in a different order, and we get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1. Square root of 5 plus 1 or divided by 2 . Okay, so now we will calculate the value of x1 times x2. We have here the expression of square root of 2 plus 1 times square root of 2 minus 1. Actually, this expression is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. So according to this algebraic identity, we will get that our expression square root of 2 plus 1 times square root of 2 minus 1 will be equal to a minus b, when a equals to square root of 2 and b equals to 1. So it equals to a squared minus b squared. A squared, a is square root of 2, so a squared is square root of 2 squared. That is to say it is 2 minus b squared. B is 1, b squared is 1 square, 1 square is 1, so it is minus 1. In conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1, that is actually 1. In the same way, we will calculate the value of the expression square root of 5 plus 1 times square root of 5 minus 1. So this expression equals to a squared minus b squared, when a equals to square root of 5 and b equals to 1. B equals to 1. So I repeat again, square root of 5 plus 1 times square root of 5 minus 1 will be equal to a squared minus b squared according to this algebraic identity, when a equals to square root of 5, b equals to 1. So a squared is square root of 5 squared, square root of 5 squared is 5, minus b squared. B is 1, so b squared is 1 square, 1 square is 1, so it is minus 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1, that is actually 4. So in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1, and we also have to divide it by 2 times 2. So here 2 minus 1 is 1, 5 minus 1 is 4, and 2 times 2 is 4, 1 times 4 is 4, and 4 over 4 is 1. So we actually found out that x1 times x2 equals to 1. I'll repeat again. We actually found out that x1 times x2 equals to 1. So what does it mean? It means that x1 is the inverse number of x2, again x1 is the inverse number of x2, and it is also true to say that x2 is the inverse number of x1. Okay, that is the conclusion that we derive from the equation that x1 times x2 equals to 1. But according to equation number 3, we've already found out that x times y equals to 1. And we have two solutions that are possible for our question. The first solution will be equal to x1, y1, and the second solution will be x2, y2. So we'll put the first solution inside the question number 3. That is to say, x will be equal to x1 and y will be equal to y1, and we will get that, according to equation number 3, x1 times y1 equals to 1. What does this equation number 3 means? It means that y1 is the inverse number of x1, y1 is the inverse number of x1, but we have already found out that we have already found out that x2 is the inverse number of x1. x2 is the inverse number of x1 here. So actually we have two numbers that are the inverse number of x1. The two numbers are y1 and x2, and according to the rule that each number has only one inverse number, that is to say x1 can have only one inverse number. x1 can have only one inverse number. So for that reason, we will conclude that y1 equals to x2. Okay, according to the rule that each number has only one inverse number, we will conclude that y1 equals to x2. Okay. Likewise, we will put the second solution to the question in equation number 3, and we will get that equation number 3 states that x times y equals to 1, and the second solution is x2, y2. That is to say, x will be equal to x2 and y will be equal to x2. So if we put the solution inside equation number 3, we'll get that x2 times y2 equals to 1. x2 times y2 equals to 1. What does it mean? It means that y2 is the inverse number of x2. y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. So we actually have two numbers, y2 and x1, that are the inverse number of the same number that is actually x2. And according to the rule that any number, each number, or any number, or every number has only one inverse number, we get that y2 equals to x1. Because of the fact that x2 has only one inverse number, we will conclude from it that y2 equals to x1, and we already found out that y1 equals to x2. In the next step, I will present to you the solution to the question. So the solution will be the first solution to the question will be x1, y1, and we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 divided by 2, and y1, we already found out that y1 equals to x2. So y1 that equals to x2 will be equal to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. Okay, so this is the first solution to the question, x1, y1, and the second solution to the question is x2, y2, x2, y2, x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and we have already found out that y2 equals to x1, so y2 that equals to x1 will be equal to square root of 2 plus 1 times square root of 5 minus 1 divided by 2. Okay, so x2, y2 is the second solution, and x1, y1 is the first solution. Okay, so that is the answer to the question. In the next step, I will summarize the lecture. So we have here square DEBF. One side of this square equals to 1 unit. The square is inside the right triangle ABC. We know that the hypotenuse of the right triangle ABC equals to 3 units. That is to say, AC equals to 3 units, and we want to find out the value of line segment FC, that is x, and the value of line segment AD, that is y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. Here, DE is parallel to BF, and BC is one side of the right triangle ABC, therefore it is a straight line. And because of the fact that part of the straight line BC, that is to say BF, is parallel to DE, then the straight line itself will be also parallel to DE. Okay, so BC is parallel to DE. Then I presented to you rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So here we have those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other. Okay, that is to say, angle AED equals to angle EFC, according to rule number 1, and if we define angle AED as theta, if angle AED equals to theta, so from this equation we will derive that angle EFC also equals to theta, this angle EFC also equals to theta, so we found out that those two angles, they are equal to each other, and they are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have AB is one side of the right triangle ABC, therefore it is absolutely a straight line. We know that AB is a straight line, AB is a straight line, so if we focus on this side of the straight line AB, at point D, and we define angle ADE as x, then angle x plus 90 degrees must be equal to 180 degrees according to rule number 2. X plus 90 degrees must be equal to 180 degrees according to rule number 2. here we subtract 90 degrees from this equation, and we will get that 180 degrees minus 90 degrees equals to 90 degrees. So we found out that angle x, this angle equals to 90 degrees. Then we know that BC is one side of the right triangle ABC, therefore it is absolutely a straight line. BC is a straight line, and therefore if we focus on the upper side of the straight line BC at point F, then the sum of the angles here must be equal to 180 degrees. So this angle is angle Y according to our definition plus 90 degrees must be equal to 180 degrees according to rule number 2. Angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtracted 90 degrees from this equation, and we got that angle Y equals to 90 degrees. So this angle is a right angle. Then we focus on the right triangle ADE. In this right triangle ADE, we know that sinus theta equals to AD over DE. Repeat again, in the right triangle ADE, sinus theta equals to AD over DE. AD equals to Y, DE equals to 1. Therefore, sinus theta actually equals to Y. Then we focus on the right triangle AFC, EFC. Here sinus theta equals to EF over FC. In the right triangle EFC, sinus theta equals to EF over FC. But EF equals to 1, FC equals to X. Therefore, in conclusion, we found out that sinus theta according to equation number 2 equals to 1 over X. Then we created the equation number 3 that states that sinus theta according to equation number 1 must be equal to sinus theta according to equation number 2. Sinus theta according to equation number 1 is Y, and it must be equal to sinus theta according to equation number 2, that is actually 1 over X. 1 over X, so we found out that according to equation number 3, Y equals to 1 over X. We multiplied the equation number 3 by X, and we got that X times Y equals to 1. What does this equation mean? It means that X is the inverse number of Y, and Y is the inverse number of X. And we also have a rule that every number has only one inverse number. Then we focus on the right triangle ABC. In the right triangle ABC, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AC squared. It must be equal to AB squared plus BC squared. According to equation number 4, in the right triangle ABC, AC squared equals to AB squared plus BC squared. AC equals to 3. So AC squared is 3 squared, 3 squared is 9. And AB equals to Y plus 1, so AB squared is Y plus 1 squared. BC is X plus 1, so BC squared is X plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to Y plus 1 squared plus X plus 1 squared. Here we open the brackets in this side of equation number 4, and we got that Y plus 1 squared is Y squared plus 2Y plus 1 plus X plus 1 squared is X squared plus 2X plus 1, and it equals to 9. Then, according to equation number 3, we know that Y equals to 1 over X, so we can substitute Y by 1 over X in equation number 4. We did it, and we got that Y squared is 1 over X squared plus 2X plus 2Y is plus 2 times 1 over X plus 1 plus X squared plus 2X plus 1 equals to 9. Then we organize the expressions here in equation number 4 in a different order, and we got that X squared plus 1 over X squared plus 2 plus 2X plus 2 over X equals to 9. Inside the brackets, the expression inside the brackets is X plus 1 over X squared, and here we took 2 as a common factor out of these two expressions, and we got inside the brackets x plus 1 over x that equals to 9. So in conclusion, we got that according to equation number 4, x plus 1 over x squared plus 2 times x plus 1 over x equals to 9. Here we defined t as x plus 1 over x, that is to say t equals to x plus 1 over x according to our definition. Now we can substitute x plus 1 over x by t. We did it and we got that here we have t squared plus 2t equals to 9. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, and the solution a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula, that is to say according to the formula that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, the variable that we are looking for is t, so x equals to t, and the coefficient a equals to 1, coefficient b equals to 2, and c equals to minus 9. So we put the data inside the formula for x, and we find out the value of t, because x equals to t. We did it, and we got that x equals to t, so t equals to minus b, b equals to 2, so minus b is minus 2, plus minus square root of b squared minus 4 times ac, so b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times ac, 4 times a is 1, and c is minus 9, so it is minus 4 times minus 9 is plus 26 divided by 2. So inside the brackets we have 4 plus 36, that is 40, all divided by 2, and we know that the square root of 40 is 4 times 10, the square root of 4 is 2, so in conclusion we got that t equals to minus 2 plus minus 2 times square root of 10 over 2, so here minus 2 over 2 is minus 1, and 2 over 2 is 1, so in conclusion we found out that t equals to minus 1 plus minus square root of 10, that is to say t has two different solutions. The first solution is t equals to minus 1 plus square root of 10, and the second solution is t equals to minus 1 minus square root of 10. We focus on the second solution. According to the second solution, t equals to minus 1 minus square root of 10, but t equals to x plus 1 over x according to our definition. And x is length, is the length of one side of the right triangle, here, triangle EFC, therefore it must be a positive number, and x plus 1 over x will be also a positive number. So in this side of the equation we have a positive number, and in the other side of the equation we have the expression minus 1 minus square root of 10, that is actually a negative number, and the positive number can never be equal to a negative number, therefore we have a contradiction here. So this answer is not correct answer, we cancel this answer, and we left only with the answer for t, that t equals to minus 1 plus square root of 10. We know that t equals to x plus 1 over x, so x plus 1 over x equals to minus 1 plus square root of 10. Here we multiplied x by x and then we divided by x, and we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied this equation by x, and we got that x squared plus 1 equals to square root of 10 minus 1 times x. And here we subtracted square root of 10 minus 1 times x from this equation, and we got that quadratic equation x squared minus square root of 10 minus 1 times x plus 1 equals to 0. Here the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solution for our quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So in our specific quadratic equation, x equals to minus b, so b equals to minus square root of 10 minus 1. And minus b is minus minus, and minus minus is plus. So in conclusion, we found out that minus b equals to square root of 10 minus 1 plus minus b squared. B squared is square root of 10 minus 1 squared, minus 4 times ac is minus 4, over 2a is over 2. So x equals to square root of 10 minus 1 plus minus. Here, square root of 10 minus 1 square is 10 square root of 10 square plus 1 square minus 2 times square root of 10 minus 4. Square root of 10 square is 10 and 1 square is 1. So here inside the brackets we have 10 plus 1 is 11, 11 minus 4 is 7. So inside the brackets we have 7 minus 2 times square root of 10, and x equals to square root of 10 minus 1 plus minus square root of 10 minus square root of 7 minus 2 times square root of 10 over 2. Then we took the expression that is inside the root and we changed it to, the expression. We actually presented it in a different way. So the expression inside the root is 7 minus 2 times square root of 10. 7 is 5 plus 2, so we substituted 7 by 5 plus 2, and we have also minus 2 times square root of 10. We substituted square root of 10 by square root of 5 times square root of 2, and we know that 5 is square root of 5 square and 2 is square root of 2 square. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2. And this expression is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. That is to say, we can substitute our expression by a minus b square when a equals to square root of 5 and b equals to square root of 2. We did it and we got that our expression equals to square root of 5 minus square root of 2 square, that is actually a minus b square. And then we substituted the expression inside the root that is 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, and we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 square over 2. So here x equals to square root of 2 minus 1 plus minus. Here we have square and root, and the square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, x equals to square root of 10 minus 1 plus minus square root of 5 minus 2 over 2. Here we have two solutions that are possible for x. The first solution is x1, that is actually square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2, and the second solution is x2. The second solution for x is x2, that equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. Okay, so x1 equals to this expression, and here we substituted square root of 10 by square root of 5 times square root of 2, and we found out that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Then we took square root of 5 as a common factor out of this expression, and we got that x1 equals to square root of 5, and inside the brackets we have square root of 2 plus 1 minus square root of 2 plus 1 Then we took square root of 2 plus 1 as a common factor, and inside the brackets we have square root of 5 minus 1. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Then we did the same process for x2. x2 equals to square root of 2 minus 1 minus square root of 2 minus 2 over 2. Here we substituted square root of 10 by square root of 5 times square root of 2. And then we took square root of 5 as a common factor. And we got that x2 equals to square root of 5 is a common factor. And inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1. Here we took square root of 2 minus 1 as a common factor. And we got that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So we have two solutions, x1 and x2 to the question. Then I presented the two solutions in the new page, and we multiplied x1 by x2. And then, so this is x1, this is x2, and x1 times x2 is this expression. Then I changed the order of this expression, and we got that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 over 2 times square root of 5 plus 1 times square root of 5 times square root of 5 plus 1 times square root of 5 minus 1 over 2. And here we found the value of square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here a equals to square root of 2 and b equals to 1. So this expression must be equal to a squared minus b squared when a equals to square root of 2, b equals to 1. So a square is square root of 2 square. Square root of 2 square is 2, and b square, b is 1. So b square is 1 square, 1 square is 1, so it is a square minus b square, it is 2 minus 1. So we found out that this expression equals to 2 minus 1. And in the same way, we found out the value of the expression square root of 5 plus 1 times square root of 5 minus 1. Here, it must be equal to a square minus b square when a equals to square root of 5 and b equals to 1. So a square is square root of 5 square. Square root of 5 square is 5 minus b square. b is 1, so b square is 1 square is 1. So it is actually a square minus b square is 5 minus 1. So in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, 4 times 1 is 4, and 4 over 4 is 1. So in conclusion, we found out that x1 times x2 equals to 1. Okay, x1 times x2 equals to 1. What does it mean? It means that here we have x1 times x2 equals to 1. It means that what does x1 times x2 equals to 1 means? It means that x1 is the inverse number of x2 and x2 is the inverse number of x1. Okay? And then we have equation number 3 that states that x times y equals to 1. We put the first solution inside the equation number 3, that is to say x equals to x1 and y equals to y1. And we got that x1 times y1 equals to 1. What does this equation mean? x1 times y1 equals to 1. It means that y1 is the inverse number of x1 for one side, but from the other side, we have already found out that x2 is the inverse number of x1. Okay, so we have two numbers that are the inverse number of x1. but x1 can have only one inverse number. And because of the fact that x1 can have only one inverse number, we must conclude that y1 equals to x2. Okay, y1 equals to x2, and then we put the second solution inside equation number 3. The second solution is x2 y2. We put it in equation number 3, that is to say x equals to x2 and y equals to y2, and you got that x2 times y2 equals to 1. What does this equation x2 times y2 equals to 1 means? It means that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. So actually we have two numbers that are the inverse number of x2. y2 and x1 are both the inverse number of x2. But x2 can have only one inverse number. And because of the fact that x2 can have only one inverse number, it means that y2 equals to x1. Okay, y2 equals to x1, and we already found out that y1 equals to x2. So the solution to the question is x1, y1, x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and y1, we have already found out that y1 equals to x2, that is to say it equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and the second solution to the question is x2, y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and y2, we have already found out that y2 equals to x1. So y2 that equals to x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, so those are the two solutions to the question. x1, y1 and x2, y2. Okay, thank you very much.